Hello everyone, welcome to Applied IoT Lecture number 9. Uh, on lecture number 8, we covered up to system integration, but as usual, before uh, continuing from there, we will look at what we have already learned throughout the lessons. So, we are coming to finish the fundamentals of applied IoT, or to learn what are the sectors of IoT that is been there from after covering the last few topics from data analytics to service providers to end users. So after covering this, right, we have covered the IoT value chain, which means that the fundamentals of applied IoT, or the main part of applied IoT, where IoT is applied to, and what are the services or businesses or um, industries, domains which are there on this field, and in which way that each, as an engineer, you can participate in these fields, or if you're going to start a new startup, or if you're going to go into the field of IoT as an engineer, what can you select? Or if you're going to even service management side, right, if you meet IoT options, that you will be ready to understand the infrastructure that you need to provide management for. So before going for all these things, let's first look at what we have learned so far. In this, we the first thing is we learned what is IoT, right? What is IoT device? What does it do? What are the main properties of it? So the main description of IoT is IoT, or the Internet of Things, describes the network of physical objects or things that are embedded sensors, actuators, processing abilities, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. This is the general definition of IoT. Then we looked at several examples of IoT devices, including cameras, smart lights, temperature control units, motion sensors, smoke detectors, so on and so forth. Um, we looked at several industrial examples such as robotic arms or smart hospital beds, right? Then we talked about autonomous driving vehicles, weather monitoring, health monitoring, and then we looked at examples of how these are being applied. I think in lecture number 7 also there were plenty of examples that were given in which are real world applications of IoT. So that was mainly done to step a little bit beyond the syllabus what we have, and to show what is available in the real world of IoT, what can be achieved and what is there, right? So that you will have a sense of uh, technologies which are out there, because if you look at IoT and those definitions in 2010, they are completely different from 2020, because the technologies keep on developing, right? Today cloud based IoT relies heavily on cloud based technology. If you go for 2000, let's say from 2000 to 2008, around that time, right, cloud based technology and IoT is not something that is being talked about in a large scale, but today we have that. Um, so we talked about another examples of how different IoT devices, either actuators or with actuators or sensors, can work together to prevent a single scenario, in this case fire extinguishing, right? Then we continued using a set of data which has been created by a single IoT device, or a set of IoT devices dedicated to monitor the environment, right? How different industries and different domains, different sectors can use that data for their advantages. So then we talked about mix and match of those things. So by now, right, looking at these examples, looking at what was given in lecture number 7, and I hope that you have studied by yourself or done some research by yourself, continued through um, some videos which are there for IoT, and understood that how IoT is being applied in the real world, right? So if somebody is asking about IoT, or if you see IoT in action in a hotel, in a hospital, in a shopping mall, or something like that, right, you will be able to recognize it. And if, as an engineer, if somebody says I have a problem like this, now I think you will be able to understand what kind of IoT solution can be applied on that matter. Then we talked about then we took an introduction to applied IoT refers to the practical application of Internet of Things, or IoT, technologies and solutions in real world scenarios across various industries and domains. It involves using IoT devices, connectivity, data analytics, and cloud platforms to solve specific challenges, improve processes, enhance decision making, and create value. Right? Then, after that, we talked about several industries which use IoT. Right? So, so we learned about practical application, we looked at examples of practical application, and by now I think you are pretty much the foundational knowledge of IoT and how IoT can be applied is with you, right? Um so the characteristics of IoT, or characteristics of IoT systems. For this, we talked about connectivity, sensing, so the perception layer, data analytics, automation control, stability, security and privacy, real-time communication, heterogeneity, edge computing. We talked about all these things. So in IoT, in a modern day IoT system, this is something to be expected. These characteristics are to be expected in a modern day IoT system. Then we went into learning about a little bit about IoT in IoT, or in industrial environments, right? Industrial or manufacturing, or things like that, how IoT is there. And we talked about machine to machine, which is a concept which was there IoT even before IoT, where a device or a system can talk to another system, or a machine can talk to another machine. We looked at those examples, and we looked at so we looked at the industrial applications, the smart grid applications, transportation, logistics, healthcare, and smart cities. So smart city is overall a combination of healthcare, smart grids, transportations, and so on and so forth. So we looked at all these topics, and so the main thing we got out of it is that M2M benefits primarily from IoT, and today the line between IoT and M2M has been blurred. But as for the syllabus, we talked about the differences between them, the scope, data sharing, connectivity, scalability, and data analytics and ecosystems. So in a modern day M2M environment, or somebody asks for you to join a M2M project, it would mimic more towards IoT designs rather than M2M legacy designs, right? Scalability, or the scalability, or the scope, or the amount of data sharing and the connectivity would not be limiting. It would be similar to a IoT system. On top of it, I also talked about they give a small example of OT or operational technology, and it is similar to M2M. Then there's IIoT as well, which are basically the same thing, right? So then uh, this so this gave us the information or the knowledge that similar to IT infrastructure or similar to the world of IT, where all the paperwork is turned into digital, we have OT operational system, or we have IoT or M2M systems which are running in companies where physical work is mostly done to maintain industrial level applications and so on and so forth. So that means that jobs opportunities which are there in IT sector is similarly there in the IoT sector, or where there is hardware working with networking in data centers, right? Servers, even the cloud technology, and so on and so forth. So the opportunities are the same, right? So from that, right, after understanding IoT, after understanding in industrial level applications, right, on chapter, I will again bring you back to chapter 7, because if you look at those applications of IoT, you will get a understanding of what we what are what it looks like when IoT is practically being applied, right? So after that, we'll started to look at market perspective of IoT, and market perspective of IoT we generally say it as positive. Then we started looking at value chains, IoT value chains. Here is the next step of learning applied IoT, because value chains in general is where you can see that IoT would have different sectors. If you are to start a new business, if you are to start a new startup, or if you are to go to work in the IoT sector or the engineering sector or service providing sector, you may come across these particular set of uh, value chains, right? Either manufacturing of devices, it could be an entire IoT, or components of IoT, which would be sensors, actuated, embedded systems, and so on and so forth. Then we have the connectivity of it. Then we have, of course, if there is a hardware device and networking, it should be followed up by a interface where the human can interact with that hardware device. That means there should be an application, right? So there should be a back end and a front end. So service enabler platforms, or basically the cloud, on-premises servers, so on and so forth, which would be the backend for data storage, security, data management, processing, batch processing, or real-time processing. Then there is the IoT application, which would be the front end of it, right? All these services, including the hardware of the devices, connectivity of these devices, the physical connectivity, switches, ports, core switches, so on and so forth, wiring, everything. So the network itself, back-end devices, right? Front-end devices, from screen, laptops, phones, to control rooms to even things like Alexa would need service management or managed services, right? All these are individual value chains making the entire IoT value chain itself, where we give to the customer a product, right? If you sell a device, that device should have application, should have the capability to network uh, uh, or between the servers and the device to exchange data, so on and so forth. And when you are selling your product, the IoT product, to the customer or to another business, then you should also with that product give managing services, where you will manage the back end, or another team, another company or another business would manage the back end behalf for your product, IoT device behalf of you. So those are depending on things. If you have a general understanding of ITSM or IT infrastructure management, ITIL, um, that side of things, you will understand that how these different companies might support different infrastructure, but end of the day there will be one company who will be giving the product and managing rest of the companies together, right? So again, like if you have a device, if you are selling a device and you are going to use a SIM or a cellular connection to your device is for functioning, right? The cellular connection or the cellular network would be provided by a, a cellular service provider. If you say Sri Lanka, or let's say Mobitel has provided this cellular service, so maintaining that cellular network is the responsibility of Mobitel itself. The customer would be paying to you, you will be paying to Mobitel to maintain that network, right? So it's the connectivity which goes like that. So either you can start a company catering, or you can start a company, you can join an industry as an engineer. If you're going to start a startup, even you can do anything you like. When doing that, you will see that either you will be connected, making a single link, right? Running a value chain, a part of a value chain, you will be a part of a value chain of a single link here, or you will be part of this entire value chain, in where you will be managing in the entire value chain with other businesses to provide a good product to the customer. Um, so we then after that, right? Where then after that we talked about IoT value chains, and we talked about what are the chain links that would be there, what are the companies that provide these chain links, what are the companies, for example, device manufacturing, connectivity providers, cloud platforms, and we talked about these things, right? We talked about application developers, then system integrators. We came up to here, right? So so to simplify things, so to say things simply, right, we are now talking about this value chain, or in another sense we can say that we are looking at the business opportunities that are there, or yeah, we can say that we are looking at these business opportunities that are there in the IoT value chain itself, right? So these companies which like I have pasted here as examples, mainly famous examples for these technologies or these uh, being a part of IoTs or applied IoT value chains. Uh, they either, right, we talked about how, okay, if you take TP-Link, Sigfox, Huawei, Cisco, Zigbee, we know that they are they are famous for providing network infrastructure, physical network infrastructure. We know Amazon Raspberry Pi, Arduino, Honeywell ABB. Uh, these these are mostly famous for providing infrastructure. Hardware infrastructure, right? The physical devices, so on and so forth. With their hardware infrastructure, of course, there will be software which is also being provided by this company. Right, we know that then after that, these hardware using the network infrastructure have to connect to the servers in this server infrastructure, right? So to connect to those servers, uh, today we use cloud technology as servers. So Microsoft Azure, IBM, Oracle, Google, even Arduino now provide a cloud service. We have Amazon Cloud Services. So they provide cloud services. In those cloud services, databases can be managed and security can be managed and so on and so forth. On top of that, applications can be hosted. Those applications will be interacting with the users who are using the IoT device or the IoT system or the data which has been created by IoT. Right. So we are now so little by little you understand what is being there, what are the opportunities which are there. We came into system integrators, right? We stopped there from application. So we are going to talk about data analytics, service providers, and users. I think the last two is going to be a little bit different from this value chain, right? But it would, like, yes, the companies would have a IoT value chain, but the end product to the customer would be different. Let me try to explain this. Data analytics and insights. Data analytics provides focus on extracting insights and value from the vast amount of data generated by IoT devices. They employ advanced analytic techniques including big data analytics, machine learning, and artificial intelligence to analyze and derive actionable insights from IoT data. These insights can help business optimization, improve decision making, and create new value added services. So you can see that in applied IoT, uh, generating information to optimize operations, improve decision making is a key thing in applied IoT, right? Or application of IoT should have those properties, right? So if you are running a IoT system, we are right now we can use cloud technology to do those analytics, big data analytics, hosting AI applications to go through that data and generate sensible information and so on and so forth. We can use them, right? So this data analytics or things like that are services which have been provided by Google Cloud or Oracle Cloud, Azure, IBM. So these clouds provide those particular functions as well as their cloud services. This is one thing. But what I want to say here is, remember the examples we talked about weather, right? If you go to our example, our these primary example here, the if you are a company who runs a IoT, who runs and maintains IoT devices to collect data from weather, right? You generate data about weather. That is your business. You maintain your devices. You have your own databases. You have your own algorithms in predicting weather. You have your real-time um, data which you supply, right? So you maintain that uh, IoT value chain from the devices. You can make your own devices, you have your own applications, you can have your own databases. So how to make money out of it, or how to make value out of it? What would be the end product? You can be like Facebook or Instagram or any other social platform. What they do is they sell data. So predictions of the weather, real-time reading of the weather, right? Wind speed, intensity of sunlight, humidity, whether it's raining or not, so on and so forth. The temperature outside, whether it's cold or hot or things like that, right? Those data can be sold for people who need them. It could be smart cities thinking to apply that information to have their lights on. Uh, Businesses that provide smart home solutions to have lights on and off at the correct time, they can buy data from your company and use that data to give their smart solution. Fishermen, airline, travelers, for remote locations can buy your data, buy your real time data, right? You can sell your real time data for them, so they can use that data to carry out their functions. So in the value chain itself, right, in the value chain itself, you will be maintaining all these things. You will be giving out to the customer, either B2B, B2C, or the user of your product. It could be application, right? It could be a weather application. You will be giving to them the data or the values that they are looking for about the weather itself. So that is also a business opportunity. Uh, so yes, data analytics and insight, yes. uh, as IT students, I think you know that when coming into artificial intelligence or data analytics, basically big data, data mining, those things, those are mostly towards storage, and handling of data itself, right? Those are different topics, so we are not going to deep dive into that side, because then we will be going off IoT. So in applied IoT, the basic concept here is to give an idea about what is IoT, what is applied IoT, uh, and in applied IoT, what are the value chains that are there. So we will, for now, stick to the basics. Here we have a diagram over here. I added this diagram just to show again that to show that in IoT what is needed to be maintained, what is needed to be uh, different components which are there, which is needed to be handled by different scenarios, right? It won't be only the developer, it won't be only the R&D sector. You will have to after developing a device, right, you have to then upgrade the device, even the physical device itself, right? We have smartphones which are better than last year, this year. Every year there will be a new smartphone with new features, new capabilities, new hardware improvements. So that means in the IoT world, in IoT value chains, not only the software part gets updated with security upgrades, and so on and so forth. Um, uh, the hardware should also get updated so that more features can be added, either more processing ability, better sensors, better weather protection, things like that, right? So it's an endless loop. Service providers, we will go to the next topic. It would be service providers. Service providers offer managed services and support to IoT developments. They assist with solutions, designs, development, maintenance, and ongoing management of IoT systems. That would be the main part: maintenance and ongoing management of IoT systems. Service providers may offer consulting, installation, monitoring, maintenance, and customer support services to ensure the smooth operation and performance of IoT solutions. Yes. So the service provider would be the person who will be giving, or who will be mainly interacting with the customer and telling them that we can give the application, we can maintain the back end of all these things and data, we can maintain the connectivity, and we can give the devices you want. We will maintain everything, right? So the managed service, the person who's doing this management side would be the one who will be interacting mostly with the customer. So in that perspective, now you can understand which kind of business is management services are. Because so let's say a factory that is manufacturing clothes would need IoT systems to maintain the temperature inside their factories, to run their machines, to run their electricity, manage their electricity systems, to run their security systems, to run their to either to logistical management, so on and so forth. So you will be the one who is if you are the service provider, you will be, so the company or the apparel, the company which is on apparel domain, or their main task, or their main product is to manufacture apparels or manufacture clothing, does not have the capability and ability to build a IoT value chain from ground up. It is much more cheaper and easier for them to go to a IoT company or a IoT service provider, right? Similarly, going to a network service provider, similarly going to a IT service provider, it is easier for them to go to a IoT service provider and tell them to build their system for them. right? uh, I think uh, I think that that particular party is understood. So they will be negotiating and taking deals from other stakeholders or other companies to build the network, to have, to build the devices, so on and so forth. Okay. Um, so here on these pictures, what is there is mostly your application end. I wanted to also show examples of the application end, right? This is what the end user will see in their control panels, right? It could be logistical purposes, power management, predictive maintenance, healthcare, so on and so forth, right? They will, end of the day, they will see their uh, uh, their um, front end of the application where data is being displayed in such a manner. So end users and customers. End users are the ultimate beneficiaries of IoT solutions. They can be individuals, businesses, organizations that leverages IoT technologies to gain specific benefits. End users include customers using smart home devices, industrial operators, optimization process, healthcare providers using remote patient monitoring. Healthcare providers using remote patient monitoring, and cities implementing smart city initiatives. So these, we talked about these things about end users and how these things. So I'm not going to repeat again and again, but again, you can see how these end users would see the data in at the end. Not every IoT control panel looks like this, but this is an example that I provide. And below here is a set of companies that provides different solutions, right? Edge computing devices, middleware, application securities for IoT and the IoT entire environment. So there are thousands of companies that provide these things. So I think now you understand what's a value chain is, right? I will a little bit elaborate more. I think that would be uh, beneficial to for this lesson, right? Because end of the day, in applied IoT, this is the part that IoT engineer or an entrepreneur who is looking to start up IoT would be, would be mainly targeting to do, right? So we will look at the value chain, and how we can build the value chain itself, where can be a part of it. Our our first part, right? Our first part would be the customer, right? We will start from this end. Right, customer would be business to business or business to customer, or basically we can say user. Here our example was making in apparels. This was our main example, right? Our main example was to make apparels. So this customer has several properties, right? The customer doesn't want to have its own IoT infrastructure, or to build their own IoT value chain. Their company doesn't have the capability or the engineering ability or the R&D to build a IoT value chain. But the company will benefit from the solutions which are given through IoT, right? That would be the first one. So this company then would connect with this is for example purposes, right? Would connect with our value chain. If you move to this side, managed services, or to put it in another way, IoT service provider, right? So this company will connect with a IoT service provider. The main purpose of the IoT service provider is to be responsible for this customer, to provide IoT services, right? That would be the main part of it. The IoT service provider would say, okay, we will give you a IoT package. You want to handle your logistics, you want to handle your security system, you want to handle your machines and the power the machines use, you want to handle the quality, you want scanners to scan the fabric or things like that, you want to maintain the temperature inside the factory buildings, you want to handle access control to have a system where either fingerprint or employee IDs can be used, maybe like RFID cards can be used to scan and mark attendance, so on and so forth. There's an entire IoT infrastructure. So this company will design, right, a IoT infrastructure to automate most of the things, right, and add value to this apparel company. This company itself would have their own, maybe they might have their own IoT products, right? They might have their own IoT products that would include applications, right? That would include applications and so on and so forth. But on top of that, there should be data management, there should be security, networking, so on and so forth, right, which is needed. So this company also handle these things. They might have in-house products as well, but sometimes not all the IoT products are there, right? The customer may have separate requirements which is unique to them. For example, scanning the fabrics, right? Every business, every company would have a security system, would have a fire alarm system, would have access control, would have attendance marking, would have power management. But not all companies have scanners to scan the fabric itself, right? In that sense, so what are we looking for here? So there will be points that they have to build custom applications. So we are moving a step back, right? There should be a first, before going a step back, there should be a device that can scan that. So there will be, right, we have to ask for a, not, let's say that this company's R&D, or that the service providers are R&D, they might have R&D, but that company will not have. They found another product from another company which provides IoT devices, right? This would be a right so this company provides IoT devices. So what happens is, right, they will procure, or they will ask, right, they will have an agreement with the following company to provide services to them, right, give the necessary products and so on. But let's say this IoT device company does not have a software development R&D section. Then, okay, now we have to go to the application development company, right? A company which has the ability to develop a application system. The application development company itself would be, let's say it would be a startup, it would be a small company, so that the application development company have to rely on another company for their backend. Let's say backend or cloud, right? So we know when coming into backend or cloud, right, if they don't have their data centers and so on and so forth, the easiest one is Azure, right? We know this. It would be from either Azure or AWS or well, things like that, right? Google Cloud or so on and so forth. So they provide application, full supported application to this company, right? These two companies, let me, okay, I'm just, okay, so these two companies, they are connected in such a way, right? They are connected in such a way that for them to provide the IoT device, or let's say hardware device, right? To provide the hardware device or the IoT device, or it could be sensors, actuators, or so on and so forth, right? It would be anything like that, right? If they want to give those things, right, that part would be given here. Now if you go back to the value chain here, if you go back to the value chain here, now you can see that the service manager is connecting to this company and saying, okay, we need IoT devices, and we need to have IoT devices to connect with these different we need IoT devices to build this IoT system which is been asked by this particular customer. So they have their own products. If they don't have their own products, they will procure those products from another company, and that company will connect with other application developers where they maintain. So you can see how the value chain grows up, right? So basically there will be one company making the device, the other company will be making application for that device, and also connecting, having developed the backend, and the backend will be maintained by either cloud services or right, how the cloud services cloud would be there, or on premises servers, depending on the requirement of the customer, that would be there. So end of the day, to maintain those cloud services, there would be hardware, right, which is needed to maintain in those. There should be, okay, one should be hardware, and similarly other should be network. So you can see how these things that interact with each other, right? Different businesses interact with each other in different ways, right? Each value chain interacts with each value chain in this world, depending on the requirement, right? It's a back and forth, right? When this company sells their product, the IoT device is they also give the application with it. They will give access to the application, backend access to some application, so they can manage that application and on security basis, because they are to manage data and so on and so forth. But if there is big problems in the backend and they needed to be updated, then so they will contact the IoT company. If it is a hardware issue, they will fix it. If it is application issue, this company have to talk to their vendor, which is the application developer, right? They have to check their side, so on and so forth. This is a thing that goes back and forth like this. Okay. Now what would be okay, that it's that side of it. But of course there will be networking also involved. So that means, right, there should be another part which is needed to be ISP, networking, depending on your what are you going to use. For example, if you are going to use cellular connections in a remote place, but here of course we don't need that. We know that this is basically a basically we need Wi-Fi, right? So we need Wi-Fi, and we need internal network connectivity. Maybe the owners of the company, let's say the factory is in one place but the headquarters is in another place. So if the headquarters want to see the data, the power consumption data, the security data, right, the production data, or the quality management data, or anything which is produced by the IoT system, they would need internet connections to see that particular set of data. So then that means that these services should be, in that case there is a set of services that is needed to be done, and that set of services, right, would require to maintain an entire network. Networks does not come easy. You have to build networks by yourself. That means there would be a hardware component to it, where we talked about Cisco systems, we talked about we talked about Cisco systems, we talked about the switches and those things that have been provided, we talked about Huawei, which gives antennas and so on and so forth. There's a so entire infrastructure which is needed to be handled. On top of that, on top of that entire infrastructure, of course, there is there will be protocols, there will be software part as well that is needed to be handled. So it is so not only hardware, to maintain that hardware there will be software, so it will be branching out. There will be more branching out towards this side, there will be more branching out towards this side, but this main company will be talking to them. So end of the day, the service provider, right, this is our main, this would be our customer, right? This would be the two that would be talking to each other end of the day, right? So in this, the service provider will promise the customer that all these things will be working fine and we will give you such and such a product, right? For the customer, the service manager, the service management, right? So all these things can be provided by one company. All these things in today's world, all these things are not managed by one company. Even the product, right, if you are a startup and you are going to support another small company, everything can be provided by you. But if it is a large scale multinational company, it would be hard, so you need to consult other companies, other ISPs on different countries, if you are to support multinational way. So in that case there will be other companies. So the customer talks to, gives the requirement, where the service management company would give a solution. That solution would include a front end, a back end for this system, networking, and the hardware device itself, right? I think from this you have an idea how these things goes to, right? General management of the entire system would be done by this, right? And there will be companies making devices, there will be companies making applications to interact with those devices. Overall there will, so these devices will be networked, and that network will be maintained by ISP providers and so on and so forth. So this are, right, you can be a company which manage a cloud database, you can be a company, work on a company which manages on premises server systems, you can be a company which provides network facilities, manage the hardware, you can be an application development company where they develop applications for IoT companies, you will be a IoT device manufacturing company, right? If you are not sure that you can build your own sensors, you can build your own if you are not sure that you can build your own sensors or actuators, or you can either plan and assemble from other hardware devices, then you have to get your sensors, actuators from other companies. So in that case you have to interact with sensor manufacturers, actuator manufacturers, embedded system manufacturers for processing unit chips, so on and so forth, right? All that gives the IoT product. And this, now you can see how complicated a value chain could be, right? It would spread like a tree. And if you are to start a business, or if you are to join a company regarding IoT, right, you will join, or you will be interacting either one or all of these situations. End of the day, the service provider, or the person who promised to manage the services, will be all this will be done by contracts and everything, right? I'm not going on to that side of things, but so end of the day, the customer and the service provider, or the service management company will be providing the customer the IoT services. Behind them, all this value chain is taking place, right? All this value chain is taking place. So I think now you understand the value chains, right? And you understand, okay, we talked about the market perception, we talked about value chains, right? Okay, I think now you have a clear idea of value chains, right? How each of these companies come into each value chain, what part of this value chain is being handled by which and each company, right? So if you are to become a IoT product owner, right, now you know what are the components of the value chain that you should address. If you are going to start a startup, you have an application developer, you have a IoT engineer or electronic engineer, mechanical engineer. You can develop your device, you can develop your applications, or you can develop your SDKs and those things for application developers to take use of APIs and SDKs, right? And you can then, if you have your device, if you have your application, you can take cloud services from cloud service providers. Then now you have a product with where humans can interact, right? You have the hardware and the software, right? You can take the sensors, actuators and everything from other companies, right? Then you can use network providers such as in Sri Lanka it would be Dialog Mobitel, but if you go outside there will be Airtel, Etisalat, British Telecom, T Systems, so on and so forth. So you can take their support to make the network. You can use your devices and you can provide support. You can provide a IoT solution. Overall, right, this is to just basically to explain what is this value chain looks like, right, spreading out. If you have seen IoT devices in action behind the scenes, this would be the value chains that will be taking place. Okay, so from this we will I will upload all these to the lesson I will upload all these things. Right, now we can go to our next set of chapters on applied IoT. So from that particular chapter, we can safely say that we have covered most of the main components of applied IoT, right? We went from what is IoT, we understood what is IoT device, what is IoT does, what are the applications of IoT. We understood the main purpose of IoT, right? We looked at mainly then market perspective for the future of IoT. There is room to build. Then we looked at the value chains of IoT, where of course the in the value chains, right, that was one of the key points. We discovered that what are the sections of value creation, and we looked at examples of different companies that have taken advantage of those sections of value creation and capitalize on it, right? Uh, then we had a look at how these as a IoT service provider, how to apply IoT, right? What are the like when you are applying IoT, what are the components that you should be collecting and how the value chain should be built. Either if a single company doesn't have the ability to build a value chain, as the IoT service providing company, you can talk to IoT device manufacturers, application manufacturers, backend support, and the network service providers to build an entire IoT application. So now we can go into rest of it, means like the subsections of these value chains, or basically where value these so if you take the value chain itself, right, what are the subsections, what are the technologies that are there in this field, what are the technologies that is used in this field, as well as um, what are the market opportunities that are there, right? We looked at the perception, and while talking in that we exclusively talked about IoT itself. But as you can now understand, IoT does not stand alone. IoT doesn't mean a hardware device which is connected to the internet itself. IoT means a set of hardware devices connected to each other, and this set of devices would make IoT system, and that system is connected to the internet itself. The IoT system or IoT application will be using in hardware technology, will be using network technology, will be using cloud technology, will be right on top of them there will be security aspect of it, data management aspect of it, then there will be communications between users where the application layer would be there. So we understand that when designing this particular thing, or if you are to provide in the value chain in IoT as a service, right, to give IoT solution, or to apply IoT for a solution, right, we should understand the IoT basic architectural overview. So we have to understand the architecture which is there to build a IoT system, right? In this lesson we will be concentrating on more. Right now, again, applied IoT is a theory part, right? There will be no we won't be looking into how IoT devices are made or so on and so forth. This is mainly to understand, uh, right? This is mainly to understand the value chain parts, components of those value chain in, and applying IoT in full, right? That would be the point, right? Um, so in this IoT applications or IoT systems have four main parts in their architecture, or we can say it has four main layers in their architecture. Layer 1, perception layer. Layer 2, transport layer. Layer 3, processing layer. Layer 4, application layer. Now, what is perception layer? Perception layer is easily we can categorize that as the hardware layer, right? Where the actual IoT device is. Here we have examples of camera, robots, sensors, and meters, right? Where you will find the sensors or the actuators or the IoT device. In the perception layer, the physical, we are talking about the physical device itself. In the perception layer, there would be a bit of edge computing as well. There would, right, there would be physical network connections and so on and so forth, right? It will be this in the physical layer, the hardware will be then connected to the network, which is normally categorized as transport layer. This is the purely the network layer, right? Routing, Wi-Fi, Bluetooth, transmission, or whatever. So you have 7 layer in networking. You have 7 layers. So those 7 layers are inside this transport layer, right? Basically, transport layer means network, right? Processing layer is your basic backend part of it, right? Web services, data centers, clouds, right? Where your application get hosted, where the data which is being produced by the perception layer, right, is transported through the transport layer into the processing layer, where it will be stored, processed, either real time or batch processing, depending on the requirement, right? And then finally, the application layer. Application layer, of course, is the layer that is there to interact with the human human itself, or the where the hardware devices are communicating with the user, right? Smart city, smart home, smart grid, smart health, right? You will find screens, alarms, notifications, visual notifications, sound notifications, which will be given, right? Or you can give voice commands to things like Alexa. You can use touch screen or keyboards to give your inputs, right? Adjust values. You can use control panels to give commands, so on and so forth, right? Application layer is the where the human interacts with it, right? In IoT, the most concentration is given to the perception layer, because that is the layer that is mostly uh, unique to IoT itself. The use of sensors, the use of actuators, right? Creation of a hardware device itself, creation of IoT device itself, right? Transportation layer is so in the transportation layer there is a part which is unique to IoT, where we discussed about protocols like Zigbee, Z-Wave, which is energy efficient and is used in uh, IoT device to IoT device communication in IoT system, right, where you have multiple IoT devices. Except for that, rest of the transport layer is entirely for in the domain of networking. If you are a student who has learned networking as a subject, I think it is easy for you to understand Zigbee and Z-Wave, those things as well, because those are also networking protocols. And if you take the processing layer, basically, again, data center, web services, data centers, clouds. It means the back end of everything, right? So, if you learn about data centers, if you learn about cloud technology, if you learn about IT service management, as if you learn about security, backup, data storage, data management, data mining, analytical, data analytics, uh, all these things happens in the processing layer, all of those things. Then of course, application layer, your UX UI designs, basically your front end, your designing, right? So from, if you take application processing layer, you those are uh, layers that are being shared with other subject lines. But in IoT itself, the unique part of IoT comes in perception layer, right, which is belongs to IoT itself, alongside a bit of transportation layer where we use networking protocols which are dedicated to IoT systems or IoT devices itself. So the basic, if somebody asks what is the basic four layers of the architecture of IoT, right? This would be the four layers. So in this lesson, we will be mainly looking into the architectural aspect of these things, and it would be mostly theoretical, right? um, Before going into the theoretical part of it, right, you can see that there are a lot of notes there. So what I'm going to do is I'm going to use the notes themselves to explain the situation, because um, then when I upload these PPTs, you will have the notes themselves to go through, so that would be easier for you. Um, and as you can see that we talked about our value chain, right? This perception layer, this transport layer, this processing layer, this application layer, where can we find this in our value chain? If you check, right, the devices are there for the perception layer, the transport layer is the connectivity, then we have processing layer, which would be so the platforms, right? Then we have the application layer over here. You can see the value chain being created, right? You can see the parts of the value chain. Then we have managed services, of course. Again, like IT services, you have to manage all these services. You have to upgrade, update. If you are managing the let's say network layer, for example, you know that you have to uh, upgrade, install patches, security patches, so on and so forth. You have to maintain the hardware. Perception layer, you have to maintain the hardware. Processing layer, you have to maintain the hardware, update the software, patching, security, so on and so forth. So you can see, right, the four layers plus the layer that would you can see in the value chain. The four layers are being represented, plus the next two chains, the next two links in the value chain would be the uh, the business of managing all these things, right? On top of, then it would be the customer, right? Another representation of all these is here, right? You can see that the network layer is managed, right? The devices, the application layer, the backend. So we can see that these things are there on the value chain itself. So what we are now doing is we are diving into the value chain and looking at what are these, right? If okay, we talk, so we know the value chain, right? So we are going to dive deep and look at different features of the value chain. So first we will be starting from perception layer. The perception layer consists of the hardware and software components that enable the IoT system to uh, perceive and capture information from the environment. This layer includes sensors, actuators, data acquisition devices, and other devices that are responsible for sensing and measuring various parameters such as temperature, humidity, pressure, light intensity, motion, and more. So we have in so when studying perception layer in IoT, not applied IoT, but in IoT we have talked about these sensors and everything. So basically what we have to in the perception layer, right, you will find your hardware devices. In those hardware devices, right, let's go to the examples quick. In these hardware devices you can see that they gather data, right? They gather data about temperature, wind speed, humidity. They gather data about proximity, speed, maybe tire air pressure, so on and so forth. They gather data about your heartbeat rate, pressure. They gather about the proximity, uh, uh, right, your fingerprint image processing, health, oxygen levels in your body, movement, temperature inside this. So motion, contact, they get the information about the temperature, the smoke which is being produced, purity of the air. They get the image, they get the temperature. So the sensors get the information, right? They get the information from your environment, and depending on the topics, right, depending on the sensor itself. Mainly sensors are there to gather information. uh, Sometimes the information which is being gathered, the raw information which has been gathered, can be translated into value through equations that we know, or from scientific breakthroughs that we have. One of the best examples is, if you have gone through like just 7, there's an example of how light sensors are being used to track your pulse, right? In that is a good example of getting raw data, using the knowledge and the equations we have, processing it and getting a value for your heartbeat. So things like that. If you have let's say uh, uh, if you know the volume of a container, using pressure sensors you can calculate the amount of liquid inside that particular container. So things things like that, right? Sensors can detect something, uh, detect some, let's say the factor X can be detected, and by knowing factor X we can get an outcome, by putting that set of data into a equation where that so for example, if you take a contact sensor, right, what I'm trying to say here is, if you take a contact sensor, right, these are inside, there are magnetometers calculate the intensity of magnets, the attraction of magnets, or the intensity of magnets, right? So these two magnets, right, when they are close together, the value should read high numbers, but when the value becomes 0, that means they are apart, right? So if you have one on the door frame and the other one on the door itself, right, when the door is closed you will find a value for in the magnetometer, but when the value becomes 0, that means we can then from that data we can say that the door is now closed or open. If the magnetometer reads 0, that means that the door is open. If it reads a value, that means it is closed, right? So that is how we can use sensing data to right, we can take the raw data, process it, and give a outcome for the result we are looking for. Then of course in the perception layer there are sensors, then the other part it would be the actuators. Actuators are the moving parts or the interacting parts. It could be actuators, could be screens. Actuators could be screens, buttons, or sounds, right? Warning, right? Steering wheel, vibrations could be there. There will be LED lights, warning lights, uh, movement of parts. Like if you take the Roomba, there will be vacuum, there will be sweeping mechanisms which will be working with motors, there will be wheels which will be working with motors. Same here, there will be motors to work with. If you have autonomous driving car, right, you will have motors driving the steering wheel. An electric car would have a large motor to drive the wheel itself, so on and so forth, right? So actuators are either uh, actuators in a way gives a outcome either visually, in sound, or in action, right? In perception layer, it's a either one or more sensors or actuators working together, right, that would create a IoT device. The sensors in the perception layer are typically connected to microcontrollers or embedded systems that collect data from the sensor and convert into digital format. This data is then processed locally, edge computing, which is the word we use for that, or transmit to the next layer of the IoT architecture for future analytical decisions. So, again, we take in raw data. The magnetometer would take in raw data, and the values of that will be processed inside a small processing unit inside this. We have heard of Arduino, we have heard of Raspberry Pi. They have a processing chip with them, they have the processing ability with them, right? So that would be so that the main data which is being filled, which will be taken from the sensor, will be processed inside the device itself, and the necessary data which is needed further processing or to be stored can be sent from the device. So the initial data processing which will be taken, so for example, if you take the Roomba vacuum, right, it will navigate throughout the house by itself, right? So if you take the smart lock, right, the fingerprint will be read by itself, the authentication will be done by itself. So it will use the internal set of data it has to authenticate. If that is the case, there should be processors taking place. If the fingerprint is taken as an image, it should do some image processing, then there should be some data points to be compared with all images. So all these things will be done in the machine itself. That particular process is called edge computing, right? So in perception layer there is a little bit, not huge number of processing taking place, but enough processing to give some meaning to the raw data which is being extracted from the sensors itself, and or to give command from that data to give commands to actuators themselves, right? They don't need to connect to the networks and go into the cloud to process that particular set of the data. So individually the IoT device would be processing that particular set of data, which means that in perception layer some processing ability or some processing power is also available, right? For those who have learned about IoT, building IoT device, or a small IoT project, if you have looked into a small IoT project, you will see that you will connect your sensor to a Arduino board or a Raspberry Pi small computer or small board, where the some of the processors will be done on that particular uh, board itself, right? So that if we are to build a bigger system, right? Then the data which is being processed by Arduino will be sent to the transport layer. The sensors take the raw data and send it to, let's say, Arduino. Then inside the Arduino there are controllers or integrated chips, which integrated microcontrollers. They will process the data and they will send it to the transport layer. So there's a bit of edge computing going on as well in the perception layer. A basic way to understand the perception layer is that when we are talking about the perception layer, it is the IoT device. The IoT device represents the perception layer. Normally, IoT devices have main three components, or we can say inside, or have four main components, right? The ability to connect to a network, right? It would have sensors and actuators, one or more sensors or actuators. It would have a power source. It would be from batteries. It would be from direct current, depending on the situation. And it would have the ability to process data. It would have some processing power as well. These are the four main features or characteristics that would be found in a device, in an IoT device, and that four characteristics together in one form or another, we call it the perception layer, right? Now I think you understand what the perception layer is. We talked about plenty of examples about perception layer, and you know where the perception layer lies on the value chain, IoT value chain itself, right? Okay, we can go to the next topic. Transport layer. In the context of the Internet of Things, the transport layer refers to the intermediate layer that facilitates the movement of data between devices, sensors, and applications within the IoT ecosystem. It it is responsible for ensuring reliable and secure communication between different components of the IoT system. Right. So so one of the points that is that they make there is one of the main points that that is there for the transport layer is that in IoT, not only the device communicating through the internet itself for maybe applications, control systems, or sending out data to a database or real-time processing, things like that. There is a connection between the sensors and the edge computing unit, or if you take the IoT device itself, whether it is a combination of sensors and actuators or just one sensor or a actuator, those IoT devices should talk to each other. And that's why we talked about in previously we talked about when coming into networking part of it. Transport layer is basically the network layer that we use protocols such as Zigbee, Zfox, LoRaWAN, things like that, which consumes less electricity, less power to communicate between IoT devices, right? So that is one of the layers. After that layer builds the IoT systems itself. From that, when the messages or the data is transported or sent into the internet itself or to the cloud itself through the internet, that would be using normal protocols which we use for networking of the internet itself. So we can the rest of the round would be the transport layer provides a communication infrastructure that allows data to be transmitted over various networks such as local area networks, wide area networks, cellular networks, and the internet. It handles tasks such as data packetization, addressing, routing, error detection, and error correction. So these are things that are normally there in networking. If you are a student who has learned networking and understand the concept of networking, right, and has studied the seven layers of networking, you will have or have a common understanding on networking. You would know why these protocols matter and why these uh, why all networks have protocols, right. Protocols are there as a method of standardization. uh, in coming future lessons, we will look at the standardization between the two layers, because remember we were talking about two network layers. Some of the networking which is done between IoT devices and IoT devices, and they use different protocols rather than the normal protocols that we use for communicating through the internet itself, right. So there is a place where when communicating, that particular data should be transferred into the internet or to a cloud. In that way, so the method of transmitting those data it should shifts from one protocol to another, and we have to talk about them as well in the future. The transport layer in IoT often relies on standard protocols such as transmission control protocol (TCP) and the user data protocol (UDP). The establish connections to establish connections and transfer data. These protocols enable reliable and connection-oriented communications. TCP or which is TCP, or lightweight and connectionless communications (UDPs) between IoT devices and applications. Additionally, the transport layer may incorporate secure mechanisms such as encryption and authentication uh, to protect the data during transmission and ensure the privacy and integrity of the IoT communications. The transport layer acts as a bridge between the perception layer, where data is collected and sensed, and the application layer, where the data is processed and utilized, right. So that is the basic understanding of transport layer or the network layer itself. Again, right, if uh, we will not go for a deep dive into networking, right, because that's a different subject line itself. So we should understand that networking in IoT breaks down to two different protocols, or two different methods, right. Let's go back to our here you will see that, okay, these are the different methods, either Bluetooth, Wi-Fi, NFC, uh, MQTT. These are protocols that is there, and cellular. These are commonly used protocols to communicate throughout the internet, right. Not only through the internet, like for example Bluetooth is a separate one which is used for data sharing in mass scale. NFC is there. NFC RFID is there for communicate very short communications, exchanging data. But to build a IoT network. Just IoT devices communicating between each other, passing data around uh, around, because IoT in different scenarios, IoT devices could be a lot. Let's say if there are smart smoke detectors, the amount of IoT devices that are there would be a lot. Let's say a 50-story building would have around 100, 200, maybe even 500 smoke alarms. And if we use the Wi-Fi connection, Ethernet connection, or something like that to connect with them, and let's say if those smoke alarms works on battery power, that means they have to preserve batteries. So using such protocols such as Wi-Fi or Internet would actually uh, degrade the energy power source very quickly. So they need a power source which so they need a protocol which use less electricity or less power to communicate, as well as a protocol which can help them to communicate without saturating cellular or Wi-Fi networking, which is being used for other activities, right? For this position, we have Zigbee, Z-Wave, Sigfox, LoRaWAN. These options are there for mainly for that, particularly for that. So that layer, and when those IoT systems want to talk to the cloud or through the internet to another IoT system, we're using Wi-Fi, so we change the protocols accordingly, right? So in the transport layer, you will find these all these connections, all this networking between sensors, between um, actuators, between edge computing as well. So here we talked about security aspect of it as well. We can use such as encryption, authentication, things like that. To do these things, IoT devices themselves should have the processing power to carry out encryption from their end if they are to send data. And So that means there should be a bit of edge computing related to IoT devices as well. In the perception layer, there should be edge computing as well. Uh, so, uh, Also in networking, there is a perception layer. We talked about it, like Cisco switches and so those things we need. Zigbee antennas, Z-Wave antennas, right? There are set of things like that as well. So in networking itself, there is a perception layer, but when coming into IoT, we put them all together. The 7 layers of IoT would the seven, normally we categorize in network into 7 layers. All those 7 layers are found in the inside the transport layer itself. Um, why do we need to encrypt data, authenticate data, and so on and so forth? Is some of the data which is being produced by IoT devices are very how to say um, very sensitive in nature. Let's say IoT devices which are being used in hospitals, which would need privacy, especially we look at privacy of patients, right? And things like that. So the data which is taken from patients have to be protected. Let's say security installation, authentication systems which that are there using IoT devices such as smart locks, security cameras, motion sensors, contact sensors, things like that. Sometimes the data which is being produced by them should not be available to um, to should not be available to other users who can listen into the transmission itself. So encryption is something that is important in the transport layer itself. uh, so now I think you have understanding of the transport layer itself. Of course, each of these when I say perception layer, right, that is not the only layer which has hardware components. Network layer has its own hardware components, from transmission towers to antennas for Wi-Fi, Bluetooth or cellular, right? They have their own routers, they have their core switches, right, access points, so cabling, right, everything is there. If you go for processing layer, of course there will be servers, the data storage process, uh, there will be processing powers. If you see server rooms, it's an entire room consisting of hardware itself. When you see a cloud, it is a set of server rooms working together around the world. So in that case, even in application layer, it's the same thing. You will have screens, you will have speakers, so every layer has its own hardware. But here the perception layer, we talk about perception layer specifically talks about IoT hardware components, right? When you talk about networking in IT, or when you talk about IT infrastructure, right, all these things are normally seen. But in here, the perception layer is there to address the physical components or the hardware components which are specific to IoT itself, which means IoT devices. We talk about IoT devices. So we talked about perception layer, transport layer. Now we are heading to processing itself, right? Okay. So processing layer. In the context of the Internet of Things, the process layer refers to the layer responsible for data processing, analysis, and decision making within an IoT system. It is a layer where collected data is transformed into meaningful information, insights, and action. So here, one of the main points that comes into mind is when sensors in IoT devices collect this particular set of data, right? When they collect this particular set of data, we talked about that there is to make them into meaningful raw data, to make them into information, right, we have to process them. That is done on the processing layer. In that processing layer, we will find data centers or clouds, or basically storage and enough processing power to handle that large amount of data which is being created by IoT. But remember that processing does not happen only in processing layer itself. In the perception layer, we find edge computing, where data is processed locally. So some of the data is actually processed locally. IoT devices has the capability of driving the process by itself. If you take the Roomba vacuum cleaner, or if you take let's say a self-driving car, right, or if you have your smartwatch with you to do the activities of those machines, right, they don't need to connect to the internet itself. They have the sensors, they have the processing power, right? Connecting to the internet and coming processing data coming back, that would be too late. So edge computing is also part of it, right? But this is specifically if we are talking about large data points and large amount of data which would need processing. This would be the part of it. The processing layer takes the raw data obtained from the perception layer and applies various algorithms, analytics techniques, and computational methods to extract valuable insights and knowledge. This layer involves tasks such as data filtering, uh, aggregation, correlation, fusion, and advanced analytics. So anybody who's doing data analytics, right, data mining, data analytics, and those things, you will have an idea of what it is means. So if you have IoT devices which are there producing lots of data points, if you have, let's say, a logistical, a set of logistical vehicles that you need to track, and let's say you have around 150 spread over a area, let's say around India, right? You want to get all the information about the speed of the vehicle. Is it going fast, or is it having vibrations to damage the goods inside? Is the temperature inside the container is okay? Things like that, to take information like that, right, and process them. Sometimes the IoT device itself produces different set of data points. The accelerometer in conjunction with a gyroscope would give the vibrations information, but that is needed to be run through algorithms to understand that particular data. And of course, data, because these are sensors, right, there will be some errors or there will be some anomalies, so those things have to be filtered as well. So sometimes that is being done on edge computing, but sometimes we need, if we have large data points, we need some processing power to handle those large amounts of data. So that is why we need servers, right? The processing, not so normally, if you have, let's say, gigabytes, terabytes, or petabytes of data being produced by IoT devices, right? A logistical system with 150 vehicles which is traveling around a country which is, you know, 10-20 times bigger than Sri Lanka, right, would produce a large amount of data. The path that is being taken, the vibrations, the health of the engine, so the health of the machinery itself, right, the goods inside the container, things like that. So those data have to be stored somewhere for analytical purposes, right? So that sometimes, you know, how can they be used? For example, if at the end point, if some things are damaged, some of the materials which were transported by a vehicle is damaged, the the data will show if these are damaged by human error or by road conditions. If the road conditions are bad, right, and that is why these get damaged, the next time they can use a different road so that they can minimize the damage. If the road conditions, if these are damaged and the road conditions are good, then the other option would be sometimes human error. So things like that can be determined through the data points that we take, and we have to take correct data and we have to process that particular set of data. uh, right now we are reaching our 2 hours for this lecture, so we will stop in here, and we will talk about the subtopics of data processing, processing layer, where we have to talk about data processing, analytics, decision making, real time processing, and so on and so forth, which will be a part of the processing layer itself, right? Then after that we will move into our other topics, but I have to say that most of these things are theoretical, uh, theoretical as well. Right now the main point is, now we understood the value chain, what are the components there, right? You have an understanding of IoT, you have seen plenty of IoT examples, we talked about plenty of IoT examples. I dedicated entire lecture to just to show you examples which are there on the marketplace, right, and the varieties and everything. So now you have an understanding of IoT and IoT environment. So we just need to go through the subcategories of this value chain themselves, right? We are just taking apart these value chain components, right? Architecture of a system would have perception, transport, processing, application layer. These are the value point links: application layer, processing layer, transport layer, perception layer, right? Maintaining all these layers would be management services, will be going to the customer. So we are now discussing the same thing in depth. So in the next lesson, right, we will start from, we will talk about processing layer, and we will start from data processing and continue from there. So thank you everyone, have a great day.